Okay, I've got a computer science exam tomorrow, and I thought the best thing to do right now would be to go over some mechanics. So, I'm going to be going over connected particles questions, specifically lifts and scale pans, mainly because I think that the hardest questions to understand in mechanics. Anyway, let's get into our first question. So, we've got a vertical rope attached to a scale pan. The scale pan has a mass of 0.5 kilograms and it's carrying a brick of 1.5 kilograms. Then it says that the scale pan is raised vertically upwards with a constant acceleration of 0.5 meters per second squared. Alright, so the scale pan is moving upwards, and they ask us to find the tension in the rope AB. So the first thing to do in this type of question is to draw your forces. So we've got a tension going upwards. We've got a weight from the brick of 1.5 g, where g is just the gravitational acceleration. So g is 9.8. Then we have a reaction force and the weight of the scale pan. Now, you might be tempted to say that the reaction force should be equal to the weight of the brick, but in this case, the reaction force is not equal to the weight of the brick because the whole system is moving upwards. Remember, it's raised vertically upwards with a constant acceleration, and the thing that's raising it upwards is the tension. So the tension is affecting the reaction force. That's why the reaction force is not the same as the weight. But to solve for the tension, we can consider just the scale pan because the reaction force is not acting on the scale pan. So if we resolve our forces and use F equals ma, we get that the tension minus 2g is equal to 2 times the acceleration, which is 0.5. And then solving for t, we get that tension is equal to 1 plus 2g, or 20.6 newtons. Then they ask us to find the magnitude of the force exerted on the scale pan by the brick. So what that's really asking for is it's asking for the magnitude of the reaction force, because the reaction force is the force from the scale pan to the brick. And if you remember Newton's third law, every force has an equal and opposite reaction. So the magnitude of this force is going to be the same as the magnitude of the reaction force. So all we need to do is solve for the reaction force. And in this case, we can consider just the brick. So all the forces acting on the brick is the reaction force and its weight, which is 1.5 g. So we can say that the resultant force is equal to the reaction force minus 1.5 g. And we know the reaction force is greater than its weight because it's accelerating upwards. And if you remember, F is equal to ma, substituting our force with mass times the acceleration, we get 1.5 times 0.5 is equal to r minus 1.5 g. Then, solving for r, we get r is equal to 15.45 newtons. And that's how you solve these types of questions. Here's another example. They give us a lift of mass 200 kilograms. It's being lowered into a mine shaft, so in this case, it's accelerating downwards. We've got a crate of mass 55 kilograms. And there's a constant upwards resistance of magnitude 150 newtons. We don't know what that is, but it's probably air resistance. Or it could be friction. Then it tells us that the crate experiences a constant normal reaction of magnitude 473 newtons. So in this case, they give us the reaction force, and we need to find the acceleration of the lift. So first, let's draw all of our forces. We've got our tension going upwards. They haven't told us the tension. We've got the weight of the crate, and they give us the reaction force. Then we've got the weight of the lift, and lastly, we've got a constant resistance of 150 newtons. Alright, so to find the acceleration of the lift, we can't consider just the lift because we have this unknown tension force. What we have to do to find the acceleration of the lift is consider just the crate, because the tension is not acting directly on the crate. Even though the tension is affecting the reaction force, the tension is not directly acting on the crate, which is why we can ignore the tension when we're focusing solely on the crate. So the forces acting on the crate are the reaction force and the weight, and because we know it's going downwards, we know the weight is greater than the reaction force. So we can say that 55g minus 473 newtons is equal to the mass times the acceleration. Then, solving for A, we get that the acceleration is 1.2. Okay, part B asks us to find the force exerted on the lift by the cable, which is basically just the tension. So in this case, we can consider the lift, because now we know the acceleration. So we can say that the weight, which includes the crate, because the weight of the crate is acting on the lift, we can say that 255g minus tension minus the upwards resistance is equal to the mass times the acceleration. Then we can solve for t, giving us tension equaling to 2043 newtons. Lastly, this is the final question. This is actually from the question book. It's different from the other questions because we've got two boxes now. So we've got a box of 150 kilograms and 250 kilograms, and the lift has a mass of 2,100 kilograms, and we need to find the tension. So considering the whole system, we can say that the weight, which is greater than the tension because it's descending, we can say that 2,500 g minus tension is equal to the mass times the acceleration, and that gives us a tension of 21,500 newtons. Part B tells us to find the force exerted by box B on box A. So for a question like this, we need to make use of Newton's third law, which states that every force has an equal and opposite reaction force. And that's really what it's asking for. It's asking for us for the reaction force acting on A. So if we consider just the box A, and we draw all the forces that are acting on A, then we have the reaction force and we have the weight. Remember, the reaction force is not equal to the weight because tension is affecting the reaction force, but tension is not directly acting on box A. So the resultant force acting on A is going to be 150g minus r, because the weight is greater than the reaction force because it's going downwards. And we know the mass as well as the acceleration, so we can solve for r from there, and we get that r is equal to 1,290. Part 2 of the question asks us to find the force exerted by box B on the floor of the lift. So using the same idea of our equal and opposite reaction forces, we can say that the force exerted by box B onto the floor of the lift is equal to the force exerted by the floor of the lift on box B, which is going to be the reaction force. So considering just box B and box A, if we draw our forces, we have the reaction force acting onto B, and we have the weight, which includes box A. So the resultant force is going to be 400g minus our reaction force. And we know the mass and we know the acceleration, so we can solve for r from there. So 400 times 1.2 is equal to 400g minus r, and then we can solve for r, giving us 3,440 newtons. And that's all the questions I'll be covering. Hopefully you know how to solve these types of questions now. And I'm gonna go get an A star in my computer science exam now.